Hello friends and my dear friends. Hello friends and my dear students. I welcome you all to my channel. This video is in this video I will solve the second practice test paper on the chapter Exponents. Uh, Today itself, a few hours before, I had uploaded the video where I solved the practice test paper 1. If you have not watched that video, I highly suggest that you watch that video, try to solve the practice test paper 1 yourself. And if you are stuck at any problem, you can see the video and see the solution. So in this video, I will solve practice test paper 2, which has again 10 questions, and the time this time, the duration of time for the test will be 40 minutes. I will try my best to solve the test paper in 40 minutes if I can. Let's see how it goes. So this is practice test paper 2 on the chapter Exponents, and this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. So let's get started. Okay, so let me first set the timer to 40 minutes. 40 minutes. Okay. Yeah, approximately it is 40 minutes remaining. So let's start solve the problems. I have the test paper on the left hand side. There are 10 questions as you can see, and I will solve the questions on the right hand side. So let's start solving the problem. The first one is, which of the following is negative? Which of the following is negative? Now, to decide whether a number in the exponential form is negative or not, we have to only consider those exponential where the base is negative. So in this this number, we will only consider whether this is negative or not. Now this is base is negative, but power is even. So definitely this is positive. This is positive. So this is not a negative. Now this is A. So let's see B. B is minus 3 cube and minus 2, and so this is obviously positive. This is positive. So positive multiplied by positive multiplied by positive is positive. Okay, now here we see both the bases, both the exponential have negative bases. Now we see this it has a power of odd. We know that any any exponential number which has the negative base, and if it has a power is odd integer, then power is odd natural number, then the numeric value, then the value is negative. So this will be negative multiplied by, this is also negative because the base is negative and the power is odd. So negative and negative becomes positive. So this is also not negative. This is not a choice. C is minus 2 square multiplied by minus 3 cube. Now this is positive because the base is negative but the power is even, and this is negative because the base is negative and the power is also odd. So this is negative. So clearly this is the choice. So the answer is choice C. Okay, let's do, while I'm solving, you can pause the video and take the screenshot for the solution, and you can solve it. You can also solve and keep the test paper while I'm solving it. Let's do question number 2. Which of the following is equal to this? Which of the following is equal to this? Okay, so the given expression is 3 to the power 6 minus 3 to the power 4 multiplied by 3 square. Now definitely we have to first evaluate this. This is 3 to the power 6 minus, we know that the product of two exponentials where the base are same but the powers are different, we just add up the powers. So this becomes 3 to the power 4 plus 2, that is 6. So this becomes 3 to the power 6 minus 3 to the power 6, this is 0. So the answer is choice C. Okay, let's do question number 3. Question number 3 is the square root of this. Okay, it is asking to find the square root of 2 to the power 36 multiplied by 3 to the power 62 multiplied by 7 to the power 34. Now, okay, so these are product of exponentials, but we know that any number, the square root of any number, let's say the square root of any number, how do we find the square root of a number? We first find all the prime factors of that number, and we find all the prime factors of the number, and the final square root will be one prime number out of every pair, the product of one prime number out of every pair. Now we see the number over here is definitely the prime factors are 2, 3 and 7. 2 and 3, 7 are prime factors, but 2 to the power 36. So we have, so the prime factorization, this is nothing but 2 multiplied by 2 multiplied like this 36 times. If you go to the basics of the exponentials, this is nothing but 3 multiplied by 3 multiplied like this 62 times. This is 62 times, and this is 7 multiplied by 7 multiplied by 7 like this 34 times. Now we have to the square root. In the square root we will have one prime number out of every pair. So the square root will be the product of primes taken 1 for every pair of primes. Now how many pairs of primes we have? How many pairs of prime 2 we have? So this is 2 into 2 into 2 into 36. So this implies 18 pairs of 2. This means 31 pairs of 3, and this implies 17 pairs of 7. So I'm writing in short, square root will be 2 into 2 into 2 how many times? Since there are 18 pairs, we will take 1, 2 from each such 18 pairs. So definitely we will have 2 into 2 into some like this 18 times. This is the square root. Similarly, we will take 3 out of every pair of 3's, and how many pairs of 3's are there? There are 31 pairs. So it will be, so 1 3 taken out of every 31 pairs gives product of 31 3's, 31 times. Similarly, we will have 7 into 7 into like this 17 times. So square root, this is nothing but 2 to the power 18 multiplied by 3 to the power 31 multiplied by 7 to the power 17. So the answer is choice D. Okay, let's do question number 4. What is 4? The value of the value of 1 to the power 1 plus minus 1 to the power square plus 1 to the power 3 plus minus 1 to the power 4. Okay, so we have given an expression like this, 1 to the power 1, then we are having 1 and minus 1 alternatively, and the powers are also increasing 1 2 3 4 like this. This is the pattern of the terms in this expression. By term I mean all the individual exponents. So like this it is up to minus 1 to the power 10. If you see, observe the powers, the first exponent, the first exponential has power 1, then the second exponential has power 2. So we have the last exponent, exponential has power 10. So we can see there are 10 terms, and in each term the bases are alternating from 1 to minus 1. So bases are 1 minus 1 1 minus 1. Okay, so now we can see that clearly this is 1, this is 1. Also we see that the next one base is negative, but the power is 2, power is even, so this is also 1. Second, third, the base is already 1, so 1 to the power any number is obviously 1. Again, minus 1 to the power 4, base is minus 1, negative, but the power is even, so this is also 1. So all the terms, all the exponentials are having ultimately the value 1. So we will have 1 plus 1 plus 1 plus 1, 10 ones, 10 ones. This is, so 1 plus 1 plus 1, so 10 ones, addition of 10 ones is 10. So the answer is choice C. Okay, so question number 5. Question number 5 is, if m by n we are given a expression on the right hand side, m by n, the rational number m by n equals 3 by 2 to the power minus 21 divided by 81 by 32 to the power minus 6, then the value of m by n to the power minus 3 is. Okay, so let's see, first evaluate what is m by n. So m by n is 3 by 2 to the power minus 21 divided by so 81, we have to convert this 81 by 32 to the power minus 6 in an exponential form where the base will be 3 by 2. Then it will be easy for us to simplify. So 81 we know is 3 to the power 4, and also we know 32 is 2 to the power 4. So this is minus 6. So now this becomes 3 by 2 to the power minus 21 divided by 3 by 2 whole to the power 4, and again to the power minus 6. Minus 6. This is 3 by 2 whole to the power minus 21 divided by, this is 3 to the power, this is the exponential is 3 to the power 4 and again to the power minus 6. So we just multiply the if we want to simplify it, we just multiply the powers. So this becomes minus 4 into minus 6, that is minus 24. Okay, now we know that a divided by b equals a multiplied by reciprocal of b, that is 1 by b, or we write 1 by b as b to the power minus 1. So similarly, if we apply this concept here, we have 3 by 2 minus 21, this is multiplied by the reciprocal of 3 by 2 to the power minus 24, which is nothing but 3 by 2 to the power minus 24 and again to the power minus 1 for the reciprocal. Okay, this is 3 by 2 by to the power 21 multiplied by 3 by 2 to the power minus 24 into minus 1, that is 24. Minus 24. So I'm applying some concepts. I'm not writing it down because I have to solve it. in 40 minutes, even though a lot of time is left. Let me quickly say that the concepts applied, I'm writing it as a side note on the right hand side. So we applied this concept that a by b raised to the power m, and again that whole raised to the power n is a by b whole raised to the power m into n. That is what we applied in simplifying 3 by 2 to the power minus 24, and that whole raised to the power minus 1. Okay. Now we see product of two exponents where the bases are same. So the result is we just add the powers. So this becomes 3 by 2 raised to the power minus 21 plus 24, and this is 3 by 2 raised to the power 3. And so the answer is choice D. Okay, let's solve question number 6. Question number 6. Okay, state whether the following statements are true or false. Okay, A is saying the reciprocal of 1 by 7 to the power 7, and again that whole raised to the power 7 is 7 to the power 49. Let's find out the reciprocal of. So let's say, for the ease of calculation and readability, let x equals to 1 by 7 raised to the power 7, and again whole raised to the power 7. Now let's simplify this. This is nothing but 1 by 7 raised to the power 7 multiplied by 7. This is 1 by 7 equals 7 into 7 is 49. Now this definitely is not equals to 7 to the power 49. So this statement is false. 1 by 7 to the power 49 is not equals to 7 by 49 because the base are different. The bases are reciprocal of each other. 1 by 7 is not equals to 7. Okay. So A is false. What is B? The value of this is 1. Okay. The value of minus 5 by 9 whole to the power 9 minus 3 into 2 minus 9. Now the power is a expression having multiplication and subtraction. You have to do this carefully. You have to do this correctly using the Bodmer's rule. So first we do multiplication and then we do subtraction. So this becomes minus 5 by 9 whole to the power, we first do the multiplication, so 3 into 2 is 6, so minus 9 minus 6 minus 3. So this becomes minus 5 by 9 whole to the power 9 minus 6 minus is 0. So any number, non-zero number raised to the power 0 is always a 1. So the statement is true. So the given statement is true. Okay. C. The value of x for which we are given an equation, so we have to solve the power x. It is saying that the value of x after we solve it is 1. So let's solve. We have to solve the x and check whether it is 1 or not. 125 by 8 to the power 5 multiplied by 125 by 8 to the power x equals 5 by 2 to the power 8. Now on the right hand side we see the base is 5 by 2, and on the left hand side we see it's a product of two exponentials where both the exponentials have the base 125 by 8, and we know that we can convert 125 by 8 to in the exponential form where the base will be 5 by 2. So now 120, okay, so let's first evaluate, do it step by step. So we have a product of two exponential 125 by 8 to the power 5 multiplied by 125 by 8 to the power x. So here we know that this is nothing but 125 by 8 raised to the power, the powers get added, that is 5 plus x equals, we know, is given 5 by 2 raised to the power 18. Okay. Now we see that 125 by 8, 125 can be written as 5 cube. Also 8 can be written as 2 cube. We have this 5 plus x equals to 5 by 2 to the power 18. So now this is nothing but 5 by 2 whole cube, and again raised to the power 5 plus x equals 5 by 2 raised to the power 18. Okay. This implies it is 5 by 2 to the power 3, and again whole raised to the power 5 plus x. This is nothing but 5 by 2, the products gets multiplied, 5 by 2 raised to the power 3 into 5 plus x. This is equals 5 by 2 raised to the power 18. Now we can see that we have on both sides we have a single exponential form and the bases are same. So we can say that the powers will be same. So this means 3 multiplied by 5 plus x equals 18. This implies 5 plus x equals 18 by 3. This is 6. This implies x equals 6 minus 5, and this is indeed 1. This is indeed 1. So this statement is true because it is saying that the value of x for which the equation is satisfied is 1, and we found out that indeed the value of x is coming out to be 1. Okay, so this is true. Let's do D. The standard form of a number is given is, okay, we have to find the standard form of 15.75 multiplied by 10 cube. Now what is this number? We have studied that we have know how to express a large number in the standard form, but the number which is given here is not actually, it's a decimal number. It's already a kind of standard form, but it's an incorrect form. So we know that this is nothing but this number given is 15.75 multiplied by 10 cube. This is a decimal number multiplied by a power of 3, and the power of 3 and 10 has power of 3. So what will be the value? The value will be, we just shift the decimal point 3 places to the right, and that becomes 15750. Now this is the number. We have to see what is its standard form. So we know that, as per my notes, if you remember, expressing a large number in the standard form, what do? We first place the decimal point after the first digits from the left. So this becomes 1.5750. The second step is we count the number of digits to the right of the decimal point, and in this case it is 4. 5750 are the digits. 4 digits are there to the right of the decimal point. So we multiply this number by 10 to the power 4. And the final step, we ignore all the rightmost zeros in the decimal part. So this becomes 1.575 multiplied by 10 to the power 4. And we have to check what is given. This is exactly what is given. So this statement is true. Okay, let's solve part E. The value of this is 7. Okay, it is saying what will be the value of 3 to the power 0 plus 3 to the power 1, and then 4 to the power 0 plus 4 to the power 1, and this whole multiplied by 7 to the power 0. We know that any non-zero number when raised to the power 0 is always 1. So this becomes 1, and 3 to the power 1 is 3. So plus 4 to the power 0 is 1, and 4 to the power 1 is 4. Again multiplied by 7 to the power 0 is 1. So this becomes, so my pen is giving problem anyway. So this is 1 plus 3, nothing but 1 plus 3 plus 1 plus 4, and this is nothing but 9. And what is the answer? The value of this is 7. It is given 7, so definitely this is false. This statement is false. Okay, let's do question number 7. Question number 7. Fill in the blanks. Okay. And the A is, if it is given 2 to the power x square is equals to 512, then what will be x? We have to find x. Okay. So definitely for the first to find the unknown x, we have to evaluate what is x square. And we know in this kind of problem, we see the left hand side is an exponential form where the base is 2 and the power or the exponent is x square. So we have to convert the right hand side 512 as in the exponential form where the base will be 2, that is a power of 2. So let's see if we factorize this, what do we get? 512, okay, the factorization will take a lot of time. Let's see if we can do it quickly. 512, I guess, is 512. 512 is it okay? Let's do it step by step slowly. Let's divide it by 4. Then we have 4 multiplied by, this is 4 multiplied by 128, I guess. 128, guess 32, 8. Okay, so this is again 4. If we again factorize 128 and take out 4 as a factor, we get 32. Okay, this is nothing but 4 into 4 into 4, 32. Again we know 4 into 8, so 4 into 8, 8 is again 4 into 2. So these are the factors, and we know we have to convert, we have to express it as an exponential where the base is 2. So this is how many 4s? We have 4 multiplications, 4 into 4 into 4 into 4. So this is 4 to the power 4 multiplied by 2, and 4 we know is 2 to the power 2. 2 square is 4. So again we have 4. This is 2. So this is 2 to the power 8 multiplied by 2. This is 2 to the power 9. So the left hand side is equal to 2 to the power 9. So now we see both the left hand side and the right hand side are in exponential form and the base are same 2. So we can equate the powers. This means x square will be equals to 9, and this implies x is square root of 9, and we know the square root of 9 is 3. So the answer is 3. Okay, let's do part B. The number whose expanded form is, a number in expanded form has been given 8 into 10 to the power 4 plus 5 into 10 to the power 1 plus 8 into 10 to the power 0. So we know when we are given a number in expanded form, we know how to get back the number, the large number. So we find the maximum power of 10, that is 4. So we immediately know that the number of digits in the large number will be 5. So we create 5 box like this, and we write the powers of the digits, the powers of the place values of the digits as 0, 1, 2, 3, 4. So meaning the rightmost digit is in the place whose value is 10 to the power 0. the second digit from the right has a value whose it has a place whose value is 10 to the power 1, like this. Now, how do we find the digits? We see the number in the expanded form. We see the 10 to the power 4, its corresponding digit is 8. So we put 8 in the box below 4. So 8 goes here, and 5 goes under 1, 8 goes under 0, and the other two boxes will be 0. So the number the large number whose expanded form is given is 80058. Okay, let's do problem 6, problem part C. If 3409 and then 50 in standard form is k to the power k into 10 to the power n, then the value of k into n is, okay. So the large number given is 3, 4, 0, 9 and then 5 zeros. 5 zeros. Yeah, 5 zeros. First, we have to first convert this number, large number, into standard form, that is in the form k multiplied by 10 to the power n. So we know the process is, first we put the decimal point after the first digit from the left. So this becomes 3.409 and then 5 zeros. The second step is we count how many digits are there after the decimal point to the right. So we have how many digits? 409, 3 digits, and then 5 zeros, 8 digits. So now we have the standard form as multiplied by 10 to the power 8. Why 8? Because we see after putting the decimal point there are 8 digits to the right hand side of the decimal point. Okay, now in the decimal number we have to ignore all the rightmost zeros in the decimal part. So this becomes 3.409 multiplied by 10 to the power 8. So this implies k is 3.409 and n is 8. So we are asked to find the value of k into n. So this implies k into n is 3.409 into 8, and that is 72, 7, 32, 24. 24.272 is the value of k into n. Okay, let's do part D. Okay, we have to simplify the value. We are given a very complicated expression. Let's see. It is minus half to the power 5 divided by minus half to the power 4, and this whole divided by minus 1 by 8 to the power 4 divided by minus 1 by 8 to the power square. Okay, so we see this is basically a division of two expressions, where each expressions again are in exponential form. So let's see step by step. Now this 1 by minus 1 by 2 to the power 5 divided by minus half to the power 4 is nothing but minus half to the power 5 minus 4, because we know that a by b raised to the power m divided by a by b raised to the power n is equal to a by b raised to the power m minus n if m is greater than n. We know this fact from the laws of exponents, and we see that m in this example is 5 and n is 4. So we can do this, write this. This becomes minus half to the power 5 minus 4. This divided by, again we will do the same thing on the right hand side. This is minus 1 by 8 whole to the power 4 minus 2. Okay. Now let's simplify the powers. This becomes minus half to the power 1 divided by minus 1 by 8 to the power 2. Okay. Now we see that the bases are different and the powers also different. So we have to apply the concept of division or division of rational numbers. So now minus half to the power 1 is nothing but minus 1 by 2, and this is division of minus 1 by 8 square is nothing but 1 by 64. It is actually minus 1 square divided by 8 square, and minus 1 square is 1 and 8 square is 64. So we have this. So now we see it is a division of two rational numbers, and we know that this is minus half multiplied by the reciprocal of 1 by 64, that is 64. This is nothing but minus 32. So the answer is minus 32. Okay. Let's see E, part E. What is saying that if 2 to the power x, what is given, let's write down that first. 2 to the power x multiplied by 3 to the power y multiplied by 11 to the power z equals 1331. Then the value of x square plus y square plus z square. Okay, so we have to eventually find the, how many time is left? 4 minutes left. Oh god. Okay, so this. So in order to find x, y, z, definitely we have to factorize 1331 into prime factors. Express that as a product of its prime factors. So let's quickly see the prime factors of 1331. We'll 9. We'll divide by 3, 3, 4, 4, no. 7, 7, 14, 14, 14, 14, 9, no, 1, 63, no, 9, 4, 4, 36, 5, no, 11, 11, 1, 23, 20, yes, I think it is 11. Oh, obviously it will divide by, see, when it is given already that 2 to the power x multiplied by 3 to the power y multiplied by 11 to the power z is equals to 131, then clearly the prime factors are 2, 3 and 11. So first let's divide by 11. It's 1, 2, 2 and 1. Okay, again it will divide by 11. This is 1, 1, and again it will divide by 11. Oh, we see this. So this is nothing but 11 to the power 3. Okay, so now we clearly see that 11 to the power. Now what about xy? So definitely it does, 1331 does not have the prime factors of 2 and 3, but we can, to find x and y, we can say always that 11 to the power 3 is nothing but 1 into 1 into 11 to the power 3. Now 1 we can always write it as 2 to the power 0, and this second one we can also write 3 to the power 0, and this is 3. So this implies if we compare the left hand side and the right hand side, the factors are same, so their powers will also be same. So this implies definitely x equals to 0, y equals to 0, and z equals to 3. So this implies we have to find x square plus y square plus z square is nothing but 0 square plus 0 square plus 3 square. This is nothing but 9. Okay, the answer is 9. What about 8? Question number 8. Uh, question number, my pen is giving trouble. Okay, the value of, okay, it is given, the expression is given 3 multiplied by 7 squared multiplied by 8, 11 to the power 8 divided by 21 into 11 to the power 6. So we see in the numerator we have factors, we have exponentials where the bases are 3, 7 and 11, and somehow we also have a denominator exponential where base is 11. So we have to definitely convert 21 as a factor of 3 and 7. So we see uh, this is a relatively easy problem. You just have to do a little bit of calculation. So 21 is 3 into 7, 11 into 6. Now this is nothing but 3 gets cancels out, 7 cancels 1 7, and we get 7 multiplied by 11 to the power 8 minus 6. This is nothing but 7 multiplied by 11 square. This is nothing but 7 multiplied by 121. This is nothing but 7, 14, 8. 847, and oh, sorry, what I am doing. So the we have to we found the result is this 7 into 11 square. We have to choose the correct choice. Which one does matches? First one, no. A, no. B, no. C, no. D, yes, because 3 to the power 0 is 1. So the choice is 3. 42 seconds left. I don't think I can complete the question, but let's see. The number as single exponential form is, okay, 2 to the power 64 whole to the power 5 divided by 64 to the power 24. Okay. Okay. So 64. So it's better either you convert both the base to as 64 or 2. I will prefer to convert the base to 64. This is, we know that 64 is 2 to the power 4. Now 2 to the power 64 I can write it as 2 to the power 4 multiplied by 16, and okay, this is 64 to the power 24. Now this becomes, so we have written 2 to the power 64 as 2 to the power 4, 2 to the power 4 into 64. 64 is 4 into 64 into 16. Now this is uh, okay. Now, so this is, we have 2 to the power 2 to the power 4 into 16, and that whole to the power 5. This is nothing but 2 to the power 4 into 16 uh, into 5, okay, divided by 64 to the power 24. Fine, okay. Now I can write it as 2, I can rearrange this exponential as 2 to the power 4, 2 to the power 4 and whole to the power 16 multiplied by 5 divided by 64 to the power 24. So now this becomes, oh no, 2 to the power 4 is how much? Sorry, I made some mistake. 2 to the power 4 is 16. Okay, let's see. 2 to the power 4 is 16. I will do one thing. I have to convert, make the base 64. So I need another, I have to make it 2 to the power 4. 2 to the power 6 is 64. 2 to the power 6 is 64. 2 to the power 6 is 64. becoming complicated. I will keep the, sorry, let's keep the base 64, let's keep the base 2. So now 2 to the power 64 whole to the power 5 is nothing but 2 to the power 64 multiplied by 5, and divided by, we have 2 to the power 4, we can write it as 2 to the power 6, and this is whole to the power 24. So now this is 2 to the power 64 into 5 is 20, 2 to the power 320 divided by 2 to the power, this becomes 2 to the power 6 whole to the power 24 is 2 to the power 24 for 144. 144. Okay, now we know that this is nothing but 2 to the power 320 minus 144. Applying the concept a by b, over here a by b is nothing but 2, that is a is 2 and b is 1. We know that this a by b raised to the power m divided by a by b raised to the power n is a by b raised to the power m minus n if m is greater than n. Clearly we see that 320 is greater than 144. So now this becomes 2 to the power, how much is 320 minus 144? This is 6, 10, 5, 7 and 1. So it is 2 to the power 176. So the answer is choice B. This was question number 9. So probably I couldn't do two questions. Two questions were left when time was out. Anyway, let's solve the problems. Find the value of n for which it is extremely hot and I am sweating very, very badly. Okay. What is the equation given? We have to solve the power unknown n from the given equation. So the equation is 2 to the power n minus 5 multiplied by 6 to the power 2n minus 4 equals 12 to the power 4 multiplied by 2 and this whole reciprocal. Okay. So on the left hand side we can see we have product of two exponentials where the bases are 2 and 6. So it's better we convert the right hand side similarly, that is product of two exponentials where one base will be 2 and another base will be 6. So let's quickly do that. We know 12 is nothing but 2 multiplied by 6. So 12 to the power 4 becomes 2 into 6 to the power 4 multiplied by 2 and this whole reciprocal whole to the power minus 1. This is, we know that 2 to the power 4 multiplied by 6 to the power 4 and we have multiplied by 2 and whole to the power minus 1. The concept applied here is a into b whole to the power m is nothing but a to the power m multiplied by b to the power m. So this becomes 2 to the power 4 we have and 2. So the power adds up. We have 2 to the power 5 multiplied by 6 to the power 4 and this is whole minus 1. Now we can say that this is 2 to the power of 5 whole to the power minus 1 multiplied by 6 to the power 4 whole to the power minus 1. The concept applied here is again the one that is already there on the right hand side as a side note. So this is nothing but the power gets multiplied. 2 to the power 5 whole raised to the power minus 1 is nothing but 2 to the power 5 into minus 1, that is 2 to the power minus 5. Similarly, this is 6 to the power minus 4. Now we compare we have expressed this as a product of two exponents where one exponent is base is 2, another exponent's base is 6. Now we compare the powers of either 2 or 6 on both sides, and we get, if we compare the powers of 2 on both sides, we get n minus 5 equals minus 5. This implies n equals minus 5 plus 5 equals 0. 0 is the answer, 0 is the result, n is 0. So the answer is choice B, and that is end. That brings to the end of solving the test paper 2. So I hope we already have 2 test papers solving, test paper 1, practice test paper 1 and practice test paper 2. This set of questions will give you a very good idea about, will give you a very good coverage of all the types of problems that can come on the chapter of exponents. I hope this video was beneficial, and until the next video, take care and bye.